What are cubic units in geometry and volume? Imagine filling a box with tiny cubes until it's completely full. Those tiny cubes are what we call cubic units. They help us measure how much space an object takes up in 3 dimensions. Think of a cube with each side measuring 1 unit long. Its volume is 1 cubic unit because it's just one small cube. If the cube's sides are 2 units long, then its volume is 2 times 2 times 2, which equals 8 cubic units. Cubic units are used to measure all kinds of 3-dimensional shapes like cylinders, cones, and spheres. When we find the volume of a shape, we're figuring out how many of these tiny cubes could fit inside it. For example, the volume of a cylinder is calculated by multiplying the area of its circular base by its height. The base area is found using the radius of the circle, and then you multiply that by the height of the cylinder. The result is in cubic units because it's telling us how much space the entire shape takes up. If you think about a water tank shaped like a cylinder, knowing its volume in cubic units helps you understand how much water it can hold. If the tank has a radius of 3 units and a height of 6 units, you find the base area by multiplying pi times 3 squared. Pi is about 3.14, so 3 squared is 9, and 9 times 3.14 is about 28.26. Then multiply that by 6, and you get roughly 169.62 cubic units. That's how much space the tank can hold. Cubic units are also useful when measuring the amount of concrete needed to build a foundation or the capacity of a shipping container. They give us a clear picture of how much 3-dimensional space an object occupies. To find the volume of a sphere, you use a different formula involving the radius, but the answer is still expressed in cubic units. In simple terms, cubic units are the way we measure the space inside 3-dimensional objects. They tell us how many tiny cubes fit inside a shape, helping us understand the size and capacity of all kinds of objects. Whether it's a cylinder, a cone, or a sphere, the volume in cubic units shows us how much space the shape takes up in the real world.